So we're doing the your turn question for example number 4 on page 319 of the pre-calculus textbook. We're doing the question, the trig equation 3 cos x plus 2 is equal to 5 secant x, and we're going to solve this for the general solution in radians. The first thing we need to do is convert this equation or rewrite this equation in just one trig ratio, and so we're going to replace our secant with 1 over cosine. So 1 over cosine times 5 is 5 over the cosine of x, and then on the left hand side we have 3 cos x plus 2. We're just going to multiply both sides of the equation by the cosine of x. When we do that, we get 3 cos x, or cos squared x, plus 2 cos x is equal to 5. And so we remove the fraction, or the denominator, which is nice, and we can see that we've got a quadratic equation. We're going to bring the 5 across, so we set our equation equal to 0. We've got 3 cos x, cos squared x, plus 2 cos x minus 5 equals 0. And I'm just going to make that look a little more like an equal sign. Now we're going to factor this. We see that we're looking for two numbers that multiply to give negative 15 and add to give positive 2. That would be positive 5 and negative 3. We rewrite our equation as 3 cos squared x minus, minus 3 cos x plus 5 cos x minus 5 is equal to 0. Grouping our first and our last two terms, we see that we have a common factor of 3 cos x, and we're left with cos of x minus 1. And we have a common factor of 5, and when we factor that out, we're left with cos x minus 1, and all of that equals 0. Finishing up our factoring, we have 3 cos x plus 5 and cos x minus 1, all equaling 0. We set each of our factors equal to 0, so 3 cos x plus 5 equals 0, and cos x minus 1 is equal to 0. Solve for cos of x. Cos of x in this case is equal to negative 5 over 3, and cos of x is equal to 1. We recognize that the cosine must be between negative 1 and 1. It has to, we can't have a magnitude or an absolute value greater than 1, and so for this factor there are no solutions. Here, if we look at our unit circle, we can see that x is going to equal to 2 pi. Now, writing this in the general solution, we recognize that x can be any rotation of 2 pi, and so we make it 2n pi, where n is an integer, and we also identify that x is from the number set of real numbers.